Welcome to our presentation. This is the third part of a series of introductory videos to the searchxml database. We are talking about the searchxml repository today. The tutorial is divided into two parts. In the first part, we explain the theory behind our repositories. In the second part, we show practical applications. Files and directories are stored in the repository, as in a file system. searchxml uses an organizational structure. At the beginning is the database. Many different databases can be created. Within the databases are the collections. These are collections of documents that are thematically or structurally connected. Within the collections, directories and files are stored. The search queries always refer to a collection of a database. Distributed queries can be used to search in different collections in parallel. searchxml differs from other database systems through its automated workflow. Update, production, and deployment are different layers of the database. New data can be copied to the top layer. They are then immediately visible as files. Within a defined cycle, these files are then fed to a production run. In a first step, they are converted to XML. Then the XML is stored in the collection. Finally, XML structures and indexes are updated. In a last step, the data is made visible via the third layer. That is, one can search in them. The middle layer will be free for the next update. Through this automated workflow, searchxml solutions providers do not have to worry about updating strategies. They are already there. There are some alternatives to transfer data to the repository. Drives can be connected to the WebDAV interface. This works on all common operating systems, on PCs and mobile devices. Using the REST or SOAP interface, programmers can transfer or modify data. The web client admin interface provides a website to maintain the repository data. There is no theory without practice, and thus we first use the admin client's web interface. We look at the repository before data is added. At the database level, we see two sub-entries. There is a database name default. A second entry denotes the home area. This is a special database that is reserved only for the private data of a user. Whether a home area is created for users can be configured. Below the database default are two collections. A collection of public documents was created during installation. The administrator sees a second collection, private cloud. Here the data of all users from the home area are stored. In our first tutorial all-in-one, we had already demonstrated how to insert data into the searchxml repository. In Windows Explorer on the right, we see the virtual drive provided by searchxml. In the Explorer on the left side we see the tutorial data. We copy only the directory office into the collection public documents. This is the other view of the repository via the web client. We update the page and now see the created directory with the Office document. This is the same file we saw in the Explorer view. We can see the status. The status shows that it has been successfully converted. You can create directories. Individual files can also be uploaded. It is easier, however, to upload a zip file with many files at once. The archive is automatically recognized and the directories and files in it are unpacked and imported into the repository. Often, the files you want to publish need to be structured. One possible form of structuring is the division into different collections. This makes sense especially when later different search strategies are to be approached. A search in a media stock requires search fields other than a search in PDF files. In the first case, you may want to enter details such as the length of the video, or the number of stars that you have assigned to an image. In the case of PDF files, one would like to formulate special search strategies, which are used mainly in unstructured texts. As an example, we create a collection named Media. When we update our Explorer, we save the new collection as a directory. We copy the audio, image and movie files into this new collection. The status shows us the new collection and that something has been changed here. As in the previous examples, the media data is converted. This time the Adobe XMP format is generated from the metadata of the media data. This is a special XML format optimized for media data. In the status display of the file, we see that a special XMP converter has been successfully applied. In the context menu of the resource, we see functions that can be specifically assigned to individual files. We have addressed this in the tutorial all-in-one. In addition, there are general file operations, such as renaming or deleting, and finally the granting of rights. We can display the effective rights of a file or directory. The effective rights refer to the current user account and include the rights to the file and the rights of all the above directories. You can also edit rights if you are authorized to do so. In the dialog for the granting of rights we see the settings for files. The searchxml rights system corresponds to the ACL standard as used under Unix, Linux and also Windows. Read and write rights to files, directories and attributes can be assigned. The rights may be related to different persons or groups, such as registered users, unregistered users, the owners group, the owner. But also, rights can be assigned for individual users or groups. Initially, the rights are not given for individual files or directories, but for the root. The rights can be inherited from there to the lower levels. You can choose whether to grant rights to only one level or any number of levels. And that's it for now. Thank you for your interest. For a deeper insight view, please also watch the other tutorials. Stay in touch on our mailing list at www.searchxml.net, or subscribe to our YouTube channel. We regularly publish interesting tutorials on searchxml. See you soon.